this is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 6-3 in the SavvasRealize Algebra 2 textbook. The goal of this video is to understand logarithms. So before I get into what a logarithm is, let's go ahead and let's talk about solving some equations. Okay, so here I have a 2 times x is equal to 8. And so to solve for x, and to undo the multiplication between 2 and x, I'm going to divide both sides of the equation by 2. And that gets me the solution x equals 4. Alright, so that act of division right there, that's called an inverse operation, right? And inverse operations are how we solve equations. So now let's take a look at this one. So here, my variable is in the exponent, so I have 2 raised to some power. Now, this is saying I could take like an x root, right? That's the opposite of a exponent. But that would leave me with 2 like 2 equals the x root of 8. Which, I mean, I could. I mean, logically, I could do that, right? I know that 8 is 2 cubed, right? So I sense that the x is 3. But really, this doesn't get me anywhere, does it? So what we have to do is we have to rethink our actions about how we deal with this right here. Okay, so the opposite of an exponential. And so what that does is that gets us this definition here called a logarithm. So a logarithm is the inverse operation of an exponential. Now notice some of the key features of the logarithm. I have a base. All right. The original power of the logarithm is now outside of the equal sign. And whatever the exponential equals is within the logarithm. Now it is worth noting that often we put the thing that's inside the logarithm in parentheses because we can put expressions in there, which you guys will see, I want to say it's example 4 or 5. Okay, so just be aware, it is often pretty common for us to put parentheses there. So let's look at how to use this equation to write a logarithmic function. So the first thing we do is we write the word log, L-O-G. Now I tend to write mine in cursive because when I write the word log, it looks like it says 10G, and I find that's confusing in the problem. So I write LOG in cursive. Now whatever the base of our exponent is becomes the base of our logarithm. So here this exponential equation has base 2, so I'm going to put a log base 2. And notice that's a subscript, okay? It's at a lower level than the rest of the equation, okay? Now the stuff that the exponential equals to, so the 8, is going to come here inside the logarithm. It's written at the same level as the log, so I wrote that one a little high. And then I put equal, and then whatever the exponent is, that's what the log is equal to. Now some textbooks, they call the log the what power function. And that's because if I go to read this as a sentence, what power do I have to raise 2 to in order for it to equal 8? That's what this reads. So what power do I have to raise 2 to make it equal 8? Well, that power is whatever x is. Okay. So let's go ahead and let's try another one where we are now writing this equation in logarithmic form. Okay, so again, you start with the word log. The base of the exponent becomes the base of the log. And the exponent is whatever the log equals. The thing that's left usually goes right here inside the log. So this is log base 8 of y equals x. Now as we move further into logarithms, this is a nice skill to have, being able to convert forms, because you might feel like this little Pikachu here, kind of stressed out, and you'll forget some of the rules of logarithms. You might feel uncomfortable with them. And so if you can remember how to convert it to an exponential, sometimes the answer kind of shakes itself out. All right, so there we have it. Until next time.